Electricity, conductors, and insulators. Imagine you want to make pasta for dinner. How do you do it? You put water in a pan and put the pan on a stove. Soon the heat from the stove burner makes the water hot enough to boil. The handle of the pan also gets hot, but the handle is not as hot as the rest of the pan. How did the heat move from the burner to the pan, but not as much to the handle? Next, you decide to turn on a flashlight to look in a dark corner in the kitchen cabinet. How does the flashlight give off light? Energy moves through a wire from the battery to the light bulb. The energy causes the bulb to give off light. But how does energy move from one part of the flashlight to the other? To answer these questions, you will look at what is happening inside the pan and inside the wire. You will have to imagine you can see what is happening to the particles in the pan and in the wire. Imagine zooming in to see what is really happening on a small scale. What is a conductor? Energy passes through some materials easily. These materials are called conductors. Conducted energy can be in the form of thermal or electrical energy. To understand how heat and electricity move, we must understand that all matter is made up of tiny bits called particles. These particles are always moving. Heat is the energy of these particles when they move. If the particles in an object move faster, the object feels hotter. Picture a pot that is put on a hot stove. The particles closest to the stove burner begin to move faster and faster. Faster particles bump into slower particles nearby and cause them to speed up. This is how heat spreads. We call this spreading conduction. Solids usually conduct heat better than liquids and gases. This is because the particles in solids are closer together. Think of having a conversation with your friends. It is easier to hear them when you are closer to them, right? Particles can communicate with each other too. If they're closer together, it happens more easily. Metals are good conductors of heat. The best conductors are metals. Silver, copper, gold, aluminum, and iron are some of the best conductors of heat. Silver and gold are very expensive. This is why most pots and pans are made out of copper, aluminum, and iron. Metals are also good conductors of electricity. Lamps, toasters, TVs, and other electrical devices are connected to electrical cords. Inside electrical cords are metal wires, usually made of copper. A cord plugs into a wall socket. Inside the wall are more wires connected to electric power lines. Power lines lead to power plants that may be hundreds of miles away. Electricity is conducted from the power plant to a lamp in your home in less than a second. What does heat flow mean? People used to think heat was an invisible material that flowed from hot things to cold things. That is incorrect. Heat does not flow like a river. Heat is energy, not matter. When something loses heat, it does not lose mass. Heat also moves slowly through the air and other gases. That is because the particles in these gases are far apart. Energy does not move easily from one particle to another. You might think this isn't useful, but in fact, that property is very useful around our homes. Many good insulators are filled with little pockets of air. For example, the walls and ceilings of many homes are filled with fiberglass insulation. This material is made of tiny pieces of glass. The fibers form a tangled mat with many air spaces. Your house can stay a different temperature than outside because of this insulation. Can you think of other places that use insulation? Fiberglass insulation inside the wall of a home. Winter coats are also insulators. They prevent heat from being conducted away from our bodies. Many winter coats are made from fluffy materials such as wool or feathers. Down clothing is a very good insulator because it has a layer of small goose feathers. Heat does not move easily through the feathers. Like all animals living in cold climates, this Arctic fox is well insulated by its thick fur. Electrical insulators prevent the movement of electrical energy. Earlier you read about electrical cords and wires. A layer of insulation always covers the copper wires that conduct electricity. This insulating layer is usually made of plastic, but it may also be made of rubber or cloth. These coverings keep electrical energy from moving where it shouldn't when it flows to other conductors. Insulation also makes electrical cords safe to touch. Wood, glass, and pottery are all good electrical insulators. Pure water is an insulator, but salt water is a conductor. Tap water is also a conductor. Most of the water on Earth isn't pure. It contains dissolved minerals. This is why you should always be careful not to operate electrical devices around water. What do you think? We often describe winter coats as warm, or we say that a thick sweater keeps out the cold. Are these descriptions correct? Remember that heat is the movement of energy, so heat moves, not cold. Iron is a heat conductor and wood is a heat insulator. You can see this is true by letting an iron hammer with a wooden handle lie in the sun on a hot day. After about 30 minutes, pick up the hammer. The iron head will feel much hotter than the wooden handle. Be careful not to burn yourself when you touch the iron parts though. The iron head feels hotter, but is it really hotter? The head and handle are actually the same temperature. Iron is a better conductor than wood, so the heat moves to your hand faster through the iron head.